Welcome to GER Hub Mathematics and Statistics lessons. In today's video, I'm going to be talking about properties of matrices part 2. Okay, so in the very first class on properties of matrices, we were able to conclude that matrix addition is commutative, matrix subtraction is not commutative, scalar multiplication of matrices is commutative, and we also concluded that matrix multiplication is not commutative. So in this video we shall look at more properties on matrices, and that will continue in a part 3 video on properties on matrices. Okay, but before we begin, please subscribe to our YouTube channel so as to make us grow. If you love us, if you want to support us, ensure that we grow by clicking the subscribe button below. Like our video, share our video, and most importantly, subscribe to our YouTube channel. Don't forget to watch our videos to learn more on matrices and so many other topics that we shall be uploading on our channel. Thank you very much. Now let us begin. Now, properties of matrices. What properties are we looking at today? I'm going to start with the first one. So, property number 1 in this video will be to show that the transpose of a matrix is the matrix itself. Okay, so when you transpose a matrix and transpose it again, it will give you the matrix itself. So let's see. Let A be a 2 by 2 matrix. Now remember, to show you all these things in the last video, I used 2 by 2 matrices as a very simple matrix to show these properties, and I want you to follow suit. You can try for 3 by 3 matrices, but why try for 3 by 3 matrices when, after all, for 2 by 2 matrices it will give you the same result? Okay, it will give you the same conclusion rather. Now let us see. So I'm going to start with a 2 by 2 matrix A. Look at what happens. So A is A11, A12, A21, A22. That is the matrix A. Now, if we are to show that this property is true, then we have to start with transposing A. If you transpose A, what would you have? Remember, transposing a matrix implies making its rows to become columns. So this row, which was A11, A12, becomes A11, A12. This manner, it becomes a column. Okay, so this row will become a column. Then this one also will become a column. So instead of being row A21, A22, it becomes column A21, A22. So what have we done? We have just transposed this matrix A to get A transpose. Now, let us now transpose the transpose of A to see if it will give us A. Now, if you do that, what is the transpose of A? What is the transpose of A transpose? Now take note, A transpose was actually writing, this was A transpose. Now if we are to transpose A transpose, it will mean converting the rows in A transpose to become columns. When you do, this row in A transpose will now become a column, A11, A21. And this other row in A transpose will become a column, A12, A22. Now what do you observe? Notice that A transpose transpose is the same as A. Do you see it? A transpose transpose is the same as A. Now let us take a simple example over here. Now if I give you a matrix A equals 1, 4, 5, 6 to show this property, you will notice that A transpose to start with will give us, changing 1, 4, which was a row, to a column becomes 1, 4. Changing 5, 6, which is a row here, to a column becomes 5, 6. Now, if I transpose A transpose, this is A transpose. So if I transpose this matrix A transpose, let's see if it gives us A. Transposing A transpose means turning this row to a column and it becomes 1, 5. Turning this row to a column and it becomes 4, 6. Notice that this result and this result are the same. Now, you can try it for a 3 by 3 matrix. If I gave you a 3 by 3 matrix, this 2, 4, 6, 1, 4, 5, 1, 6, 8. Notice that B transpose would give me this. 2, 4, 6, which was a colon, or which was a row, 2, 4, 6, which was a row, becomes a colon. 1, 4, 5, which is a row, becomes a colon. 1, 4, 5. And 1, 6, 8, which is a row, becomes 1, 6, 8 in B transpose. Now let us transpose B transpose and see. If you transpose B transpose, it means this row in B transpose 2, 1, 1 becomes 2, 1, 1, a colon. This row in B transpose 4, 4, 6 becomes a colon. 4, 4, 6. This row, the last one in B transpose, which is 6, 5, 8, becomes 6, 5, 8. Notice that this result is the same as the matrix B. So what have we shown? We have been able to show that A transpose transpose is A. If you transpose the transpose of a matrix, it will give you that matrix. So if you transpose the transpose of a matrix, it will give you what? The matrix itself. Thank you very much. Let's go to property 2. Now, for property 2, let us see what property do we need to show next. We want to show that the if you take the product of a scalar and a matrix and then transpose it, for property 2 in this video, if I transpose the product of a scalar times a matrix, the result will be the same as the scalar times the transpose of that matrix. So let us see if that is true. Again, I'm going to use a 2 by 2 matrix, A. So let A be a 2 by 2 matrix. Okay? Let K be a scalar. Now, if A is a 2 by 2 matrix and K is a scalar, then Ka will be equal to using K to multiply A11, A12, A21, A22. What would that give us? It will give us Ka11, Ka12, that is using the constant now to multiply each element in that matrix. This will give us Ka21 and Ka22. So what will that be? Ka transpose, if you now transpose this result, you end up having transposing this, okay? That will give us the transpose. This colon, this row rather, becomes a colon. This will become Ka11, Ka12. Transposing this will give you Ka12 or Ka21 and Ka22. So what have I done? I have just transposed Ka. Now what did I start with? The property says transposing the product of K and A is equal to K times the transpose of A. So what have I done? The first thing I did was to use K to multiply a 2 by 2 matrix A. After multiplying the matrix, it gave me the result of multiplying K by A11, K by A12, K by A21, K by A22. And that was how I obtained this result. Thereafter, I took the transpose. The transpose means making the rows to become colons. So I made this row a colon. I made this row a colon. And that gave me this result. Now, the next thing we have to do is to obtain A transpose. A transpose, K times A transpose will give us K times A transpose. What is A transpose? The matrix A was A12, A11, A12. So this colon or this row will become a colon here. And this will be A11, A12. If I make this row here a colon, it becomes A21, A22. So this matrix in the bracket here is the transpose of A, in which case I have made the A rows to become colons in A transpose. So A11, A12 was a row in A, it became a colon in A transpose. A21, A22 was a row in A, it became a colon in A transpose. Now, if you use K to multiply A11, you are going to have Ka11. If you use K to multiply A21, you are going to have Ka21. If you use K to multiply A12, you are going to have Ka12. And if you use K to multiply A22, you are going to have Ka22. So, compare both results. The results you had for, if you check the result we had for Ka all transpose and the result we have for K times A transpose, you will notice they are the same. So what does that show you? It shows you that Ka transpose, a scalar multiplying a matrix or transpose, is equal to the scalar times the transpose of the matrix. Now let us take an example on that property. Let's take an example on that property and see what that means. So as an example, let K be equal to 2. Let A be equal to a 2 by 2 matrix 4, 6, 9, 1. Now, what is Ka to start with? Ka will be using 2 to multiply the matrix A, 4, 6, 9, 1, and that will give us, using 2 to multiply each element. 2 times 4 will give us 8, 2 times 6 will give us 12, 2 times 9 will give us 18, and 2 times 1 will give us 2. Okay? Now, when you do that, we have obtained Ka. So the next thing we are going to do is to obtain Ka transpose. Ka transpose will be transposing this matrix, which is Ka transpose will be to transpose this matrix, which is what? Ka. So if you transpose Ka, what are you going to have? You are going to have 8 and 12. That is, this row becomes a colon. The second row becomes second colon, and that will be 18, 2. Now, this is Ka transpose, Ka all transpose. Now, we will now obtain the transpose of A. What is the transpose of A? The transpose of A transpose will be you transposing this matrix. 4, 6 is a row, it becomes a colon here, 4, 6. 9, 1 is the second row, it becomes a colon here, 9, 1. So that is the transpose of A. Now, if you take a K to multiply A transpose, that will give you, using 2 to multiply 4, 9, 6, 1. What would that give you? It will give you 2 times 4, which is 8, 2 times 9, which is 18, 2 times 6, which is 12, and 2 times 1, which is 2. Notice that the result for Ka transpose is not, the result for Ka transpose is not different from the result for Ka transpose. That is, K times A all transpose gives the same result as K times A transpose. Okay? Now, that shows property 2. So you go over it again. Take note, it applies to even 3 by 3 matrices and any other type of matrix. This property applies to any type of matrix at all. I'm only in this video using 2 by 2 matrices to show you how it is done. You can try your hands on 3 by 3 matrices and any other type of matrix at all. 3 by 1, 4 by 4, 4 by 2, it will work the same way. Okay? You try it and get back to me in the comments if you have any problem. Okay? Now, let us go to property number 3. Let's go to property number 3 in this video. For property number 3, let us consider the property that states that BC transpose is equal to C transpose B transpose. So let's see this property number 3. Now, what this property tells you is that if you are given two matrices A and B, let B and C be two by two matrices. Okay? If you want to show that this property is true, then let us consider two by two matrices, because 2 by 2 matrices are conformable. If B is a 2 by 2 matrix, it conforms with C. So I'm going to start with multiplying BC. If you multiply BC, B will be the general matrix B, B11, B12, B21, B22. Okay? Now, if I multiply this by C, this will be C11, C12, C21, C22. Okay? Now, multiplying both of them will give us the result, this. B11 times C11, use the first row to multiply the first column. So that will be B11 times C11 gives B11 C11 plus B12 times C21 gives B12 C21, close bracket, then plus, use this first row to multiply the second row now, and that will give you B11 times C12 that will be B11, C12, that will be B11, C12, plus B12 times C22, that will be B12, C22, and that ends that. Now you now come over to this. Use the second row to multiply each column. B21 will multiply C11 to give you B21, C11, plus B22 will multiply C21 to give us B22, C21, close bracket, open bracket. Now for the second row multiplying the second column, that will be B21 times C12 plus B22 times C22. Okay, that will give you the matrix. Now let's now see what BC transpose will be. Having obtained BC, let us now obtain the transpose of BC. To obtain the transpose of BC would require that we change this row to a column. So this row will become B11 C11 plus B12 C21, and this will now come B11 C12 plus B12 C22. Okay, so I have just made this row a column here. I've made it a column. Now I'll make the second row a column here, and that will be B21 C11 plus B22 C21. This will be B21 C12 plus B22 C22, and that gives me this matrix. It gives me BC transpose. Okay, now having obtained BC transpose, let us now see what the result will be for C transpose times B transpose. Let's see what that result will give us. So the first thing I'm going to write out here is C transpose. What is C transpose? C transpose will be U. This is C. Okay, so if you transpose C, it means writing the row in C, which is C11, C12, to become a column. C11, C12. Writing this row C21, C22 to become a column, it becomes C21, C22. Okay, then bring the matrix B transpose here. Now the matrix B is this. B11, B12 was a row, it becomes a column here. B11, B12, B21, B22, which was a row here, becomes a column. B21, B22. Now if you multiply, that will give us a result, and we want to compare the results are the same. So let's multiply and see. Now multiplying means using this row to multiply each of these columns. Okay, so that will be C11 times B11 plus C21 times B12. Okay, now the next one will be C11 times the second column. Now the first element here, C11 B21 plus C21 times B22 will be C21 B22. Okay, now if you come over here, you end up having the second row multiplying each of these columns, and that will be C12 times B11, C12 times B11, C22 times B12. So this will be C22 B12. Then we will use the second row to multiply the second column, and that will be C12 B21, that is this times this, then plus this times this, C22 B22, and that gives us that result. Now take note of one thing. You will notice that we can actually arrange or rearrange this result. Let's rearrange this result. If you rearrange this result, you end up having B11 C11. You end up having B11 C11. That is, I'm bringing B forward before C, and I will bring that B12 C21. Close bracket. Come over here. You do the same thing here. B21 C11 plus B22 C21. Okay, now I'm going to do it for this one. B11 C12 plus B12 C22. Then I'll do it for this. B21 C12 plus B22 C22, and that gives us the same result as this. Now this was the result for B times C. B times C gave us this result. If you compare this result of B times C with this result, you will notice they are the same. So what does that tell you? It tells you that B times C all transpose is the same thing as C transpose times B. Notice that it is not B transpose times C transpose. It is C transpose times B transpose. So when you multiply two matrices and thereafter take their transpose, the result is the same as you taking the second matrix all transpose times the first matrix transpose. Now, let us take a concrete example. Let us take a concrete example and let's see how that goes, okay? If we take a concrete example, let's assume that I am giving you a matrix 1, 4, 6, 1. And I'm giving you a B matrix 2, 4, 1, 8, okay? So, I'm giving you these two matrices. If I give you these two matrices, this and this, to test that property. Now, we want to show that A times B all transpose is equal to B transpose times C times A transpose in this case. That's what we want to show. So what we do? We are going to start with multiplying A times B. If you multiply A times B, what would it give you? 1641 times 2418. That will give us, using this to multiply this, of course by now you should be used to the routine. 1 times 2 is 2 plus 4 times 1 is 4. Okay? Then we will use this same first row to multiply this second row and second column, and that will be 1 times 4 giving us 4, 4 times 8 giving us 32. Now go over to the second row. Second row times first column will be 6 times 2 giving us 12 plus 1 times 1 giving us 1. Then use the second row to multiply the first column, the second column. That will be 6 times 4 giving us 24 plus 1 times 8 giving us 8. And your result overall will be 2 plus 4 is 6, 4 plus 32 is 36, 2 plus 1 is 13, 24 plus 8 is 32. So this is the result you would obtain for A times B. So what next are we going to do? We are thereafter going to take, having obtained A times B, we are now going to take AB all transpose. If you take AB all transpose, it will mean making this row to become 636, a colon in AB transpose, making the second row, which was a row here, to become 1332, a colon, okay? And that will be AB transpose. Now that we have obtained AB transpose, let us now check whether B transpose A transpose is equal to the same result. So I'm bringing B transpose here and multiplying it with A transpose. Now let us see what was our A. Our A was 1461. So I'm going to change this. A transpose will now have the first row becoming a colon. So in A transpose, 14 becomes a colon. 61. So in A 14 was a row, it becomes a colon in A transpose. Okay? So 61 was a row, it becomes a colon here, so this will be 61. Now for B transpose will be transposing the matrix B. 2, 4 is a row, so in B transpose it becomes a colon. 1, 8 is a row in B, it becomes a colon 1, 8 here. Now, having done that, let us now multiply. This will be using this to multiply this, that is row 1 will multiply colon 1, that will be 2 times 4 which is 8 plus 1 times 4 which is 4. Row 1 will multiply colon 2 and that will be 2 times 6 which is 12 plus 1 times 1 which is 1. Now, row 2 will multiply colon 1 to give you 4 times 4, which is 4, plus 8 times 4, which is 32. Row 2 will then multiply colon 2, and that will be 4 times 6, which is 24, plus 8 times 1, which is 8. Now, this will summarize to give us the result. 8 plus 4 is 12, 2 plus 1 is 13, and what do we have? 4 plus 32 is 36, and 24 plus 8 is 32. Now let's check. I want to believe I made a mistake here. Let's check this again. 2 times 1 gave us 2. Okay, using this to multiply this, 2 times 1 should have given us 2. Okay, not 8. So that means 1 times 4 gave us 4. So this should not be 12, but this should be 6. Now, having corrected that, note that the result we obtain for A, B transpose is the same result we are obtaining for B transpose, A transpose. And that concludes that AB all transpose is equal to B transpose, the second transpose times the A, the first transpose. Okay? And that concludes this property. Now, that being said, we have taken 3 properties in this video. Let us take another property. Let us take another property, and that will be property 4. That will be property 4. So for property 4 in this video, for property 4, let's see. Now, I have A plus B all transpose is equal to A transpose plus B transpose. This is what we want to show. So again, I'm going to be using a 2 by 2 matrix. So let A and B be 2 by 2 matrices. Then A will be A11, A12, A21, A22. What will be A transpose? A transpose will be equal to A11, A12. What have I done? I have changed this row to become a colon. So if I do that for row 2, to make row 2 a colon, this will be A21, A22. Okay? Now I have obtained A transpose. B transpose, let's start with B. B will be B11, B12, B21, B22. So what is B transpose? B transpose will be equal to making row 1 a colon. That will be B11, B12. Making row 2 a colon 2, B21, B22. Okay? Now, let us go to A plus B. A plus B. Now, A plus B will be you adding A, which is A11, A12, A21, A22. A plus B will be you adding A to B, B11, B12, B21, B22. Now, when you do that, you end up having your result as A11 plus B11 gives A11, B11, A11 plus B11. Then A12 plus B12 becomes A12 plus B12. Okay? Now, A21 plus B21 will give us A21 plus B21. A22 plus B22 will give us A22 plus B22. Now, let us transpose A plus B. This result we have obtained for A plus B, let us transpose it. So if you transpose the result for A plus B, what are you going to have? You are going to have A11 plus B11, becoming the first row here becomes a colon, and this will now be A12 plus B12. Now, for the second row, making the second row a colon will give us A21 plus B21, A22 plus B22. Okay? And that gives us A plus B transpose. Now we are going to compare that result with adding A transpose to B transpose. Let's see. So A transpose plus B transpose will give us, what did we have for A transpose? Let's put it here. What did we have for A transpose? We had A transpose to be this. So I'm going to put A transpose here. A11, A21, A12, A22 was the transpose of A. If I add it to B transpose, what did we get as B transpose? We got B11, B21, B12, B22. Now, let's add and see. If you add that, you end up having this result. A11 will add to its corresponding element, B11. A21 would add to its corresponding element, B21. A12 would add to its corresponding element, A12 plus B12. A22 will add to its corresponding element to give A22 plus B22. Now, notice something about the results. You will notice that the result we obtain for A plus B all transpose is equal to the result we have just obtained for A transpose plus B transpose. And that shows the result to be true. Look at the two results, compare these results and this result. You will notice they are the same, okay? Now, let us take a concrete example to show this. So, I'm going to give you a concrete example to illustrate that. Let's see, if I gave you a matrix 4, 6, 1, 2, and you got the transpose to be A transpose equals 4, 6, 1, 2. And I give you another matrix B, which is equal to 1, 4, 6, 8, and you transpose B, and it gave you 1, 4, 6, 8 as a transpose. Now, what will A transpose plus B transpose give to you? A transpose plus B transpose will be 4 plus 1. That it will be A, okay, let's write it this way. 4, 1, 6, 2 for A transpose, 1, 6, 4, 8 for B transpose. Summarily, the result will give you 4 plus 1, which is 5, 1 plus 6, which is 7, 6 plus 4, which is 10, and 2 plus 8, which is 10. Okay? So that will be A transpose plus B transpose. So let us see if that result will give us the same as A plus B in bracket all transpose. Now let's see. So to show if that will be the case, let's see. Now I'm going to put here A plus B. A plus B would be you adding 4, 6, 1, 2 as a matrix to the other matrix here, which is the other matrix is the matrix B. The matrix B is 1, 4, 6, 8. Now, if you add both of them, you are going to have 4 plus 1, which is 5, 6 plus 4, which is 10, 1 plus 6, which is 7, and 8 plus 2, which is 10. Now, if you transpose A plus B, if you end up transposing A plus B, you will end up having 510 will become a colon 510, 710 will become a colon 710. And if you look at it critically, you will know that this is the same result we got for A transpose plus B transpose. So you compare, let's see, this is the result we obtained for A transpose plus B transpose, 5, 7, 10, 10. And that is the same result we are obtaining for A plus B all transpose, 5, 7, 10, 10. Okay? Now, that brings me to the end of property 4. Let us now go to property 5. For property 5, which is the last property I'm going to be taking in this video, let's see, for property 5 of this video on properties of matrices, we want to show that A times the identity matrix is IA and will give us A. Okay, we want to show that this is true. So I'm going to take a 2 by 2 matrix. Let A be a 2 by 2 matrix. Full stop. Let I, remember I represents the identity element. So let I be, I represents the identity matrix, sorry. So let I be a 2 by 2 identity. Let I be a 2 by 2 identity matrix. Okay? Now let's see. We want to multiply AI first of all. So that will be A11, A12, A21, A22 times the identity matrix, which is 1, 1, 1, 0, 0. That's the identity matrix. So let's multiply. If you use this to multiply the first column, that will give you A11 times 1, which is A11. A12 times 0 will give you A11 times 1 is A11. A12 times 0 will give you A11, and then it will give you 0. Okay? Then you now use the first row to multiply the second column. This will be A11 times 0, which is 0, plus A12 times 1, which is A12. Okay? Now, A21 times using the second row to multiply each of these columns, A21 times 1 will give you A21 plus A22 times 0 will give you 0. Then using this second row to multiply the second column, A21 times 0 is 0 plus A22 times 1 will give you A22. And if you add these results, you are going to end up having A11 plus 0 is A11, A12 plus 0 is A12, and A21 plus 0 is A21, and finally A22 plus 0 is A22. Okay, so now let us go to the next part. We have just obtained the result for AI, and notice that AI gives you the same result as A, this matrix here. Okay, the result for AI is the same as what? As A. Okay, now we will now take IA and see if it gives us A. IA would be you putting 1 0 0 1 before A, which is A11, A12, A21, A22. Okay, now if you do that, let's multiply again. Use first row to multiply first column. That will give you A1 times A11 is A11. 0 times A21 is 0, so this is plus 0. Then 1 times A12, using the first row to multiply the second column. 1 times A12 is A12. 0 times this is 0. Using the second row to multiply the first column, 0 times A11 is 0 plus 1 times A21 is A21. 0 times A12 is 0 plus 1 times A22 is A22. If you add and summarize, you will end up discovering that your result will be A11 plus 0, which is A11, A12 plus 0, which is A12, A21 plus 0, which is A21, and finally A22 plus 0, which is A22. This confirms that IA is also equal to A, even as AI is equal to A. So it shows that AI is equal to IA is equal to A. Now, let us take an example to conclude this video. Let's take an example. If you take an example, you will notice this. So as an example, let us take this. So if I give you a matrix, A equals, let's use a 1 by 1 matrix, a 2 by 1 matrix in this case, 4 6. Okay, okay, let's maintain this. I'm going to maintain 1 2. Let's give a 2 by 2 matrix. Then I have a matrix B, which is I, the identity matrix, equals 1 1 0 0. Now, what is AI? AI will be you using 4 1 6 2 to multiply the identity matrix 1 0 0 1. Why I use the identity matrix in this case, why I changed this matrix quickly was because, take note, your identity matrix must be a square matrix. So I was about using a column matrix, and that does not work. Okay, now if you obtain AI, it will give you 4 times 1, which is 4, plus 1 times 1, 1 times 0, which is 0, 4 times 0, which is 0, plus 1 times 1, which is 1. What have I just done? I have just used the first row to multiply the first column, and I've also used it to multiply the second column, and that will give us this. See, I'm using the second row now to multiply the first column. That will be 6 times 1, which is 6, plus 2 times 0, which is 0. I'll use it to multiply the second column. 6 times 0 is 0, plus 2 times 1 is 2. So that will summarize to give us 4 1 6 2. That is 4 plus 0 4, 0 plus 1 1. Okay, 6 plus 0 is 6, and 0 plus 2 is 2. Again, 4 plus 0 is 4, 0 plus 1 is 1, 6 plus 0 is 6, and 0 plus 2 is 2. Notice that this is the same result as the matrix A. Now, if you try it for IA, bringing your identity matrix forward and bringing this one backwards, you end up getting the same result. This will be 1 times 4 4, 0 times 6 0, 1 times 1 1, 0 times 2 0, 0 times 4 0, 1 times 6 is 6, 0 times 1 is 0, 1 times 2 is 2, and that will give us 4 plus 0, which is 4, 1 plus 0, which is 1, 0 plus 6, which is 6, and 0 plus 2, which is 2. And that shows that A times I is equal to I times A in general and is equal to A. And that concludes this video. Please like this video, hit the like, share the video, watch the video, and most importantly, please subscribe to our YouTube channel even as you watch the video. Watching the video is very, very important because it helps you to know what we have done and to know about the topics and problem solving in the topics we have treated. Please like the video, share the video, watch the video extensively. Please watch our videos, and most importantly, subscribe to our YouTube channel, and I'll see you in the next class. Thank you very much. Thank you very much, and thank you very much.